All right, so without further ado, it's my pleasure to present the Internet Society Speaks. Ladies and gentlemen, Jerry Pesner and David Solomanoff.
Thank you, thank you. Hello, ladies and gentlemen, and extremely bright lights. So, not that I can see any of you, but I'd like to take a quick poll before we begin. How many of you would say that you are involved in internet governance issues? All right, I can see briefly like 2 or 3 hands. How many of you have called your congressman or otherwise gotten involved in the net neutrality debates? Yeah. All right, I got news for you. You're involved in internet governance. And as we go through this presentation, you're going to see why. But for right now, let's get started with the history of internet governance. We're going to go all the way from the very beginning, all the way to the possible and zany futures. So, so let's talk about how the internet actually began. This began in the mind of J.C.R. Licklider when he envisioned the intergalactic network that was going to link all the computers in the world together, of which there were maybe on the order of 10 to 20. So you can imagine, why would we need to link these things together? And you know, these days it sounds like a foregone conclusion, but think about what computers were like then. These were giant information processing machines. You fed data into them, and you got data back out of them. You know, there was no questions of using them to learn, really research things, or to find novel discoveries beyond what you were already doing with your data. They were just giant, room-sized, bulky items, and now this guy wanted to link them together for some reason. Now, J.C.R. Licklider only had a small 2-year tenure at ARPA, where he was, but he wasn't able to get it off the ground at that point. So Robert Taylor, his protege, was the one who actually did it. And Leonard Kleinrock at UCLA hosted one of the first nodes. Kleinrock had published research in the packet switching technique that we all know and love today. And his grad students, Vint Cerf, Steve Crocker, and John Postel, ended up forming something called the Network Working Group to elicit and to discuss new ideas for this emerging ARPA network. And they sought requests for comments, or RFC, on ARPANET's development. Now, the cool thing about the Network Working Group was that anyone could participate. Of course, when we're talking about a network of 4 nodes, that's not really a whole lot of people. But the good news is that as we got more nodes, we got more people. And since the object of the group was to talk about the network, it was sort of a self-propagating and beneficial feedback loop. Anybody who wanted to get involved was really able to, and there was no question of exclusion or backlash as long as you were able to play nice with other people. And because people were collaborating and working together, they were able to develop a lot of foundational protocols and software that are foundation to the internet today, such as email. That was a combination of the already existing FTP protocol plus some messaging systems customized for different nodes in the network. So, as the ARPANET continued to develop, people realized that this packet switching network thing was actually a pretty cool idea. And others started to prop it up. We had the Aloha Net, and in the 80s, the NSF Net, and a few other networks. BBN was trying to establish its own network. I think IBM was as well. So before we know it, we had dozens of, or maybe not dozens, but a whole bunch of different packet switching networks. The problem is they all work differently. The ARPANET had these interface messaging protocols that sort of governed how traffic was directed, but others worked differently. And it was just, these were all kind of on their own networks. These were railroads with no interconnection. And so Vint Cerf and Bob Kahn developed the transmission control protocol, and literally they called it transmission control protocol / internet protocol. The idea being that they could use this protocol to internetwork the networks. It didn't matter what kind of data you were sending. TCP/IP was just focused on getting the data from one place to the other. Then the networks could do with it as they wanted to. They could insert their own protocols closer to the endpoints. What was cool about the TCP/IP protocol is that it was open source, or what we know today as open source, because they just shot it out to the Network Working Group and said, here, look at this thing. What do you think of it? And then they were able to take it and improve upon it and eventually implement it on the emerging popular Unix system in the late 80s. This is how Sun computers became very popular, because you could include TCP/IP at no extra cost. Again, seems a given today, but at that point it was most definitely not. So now we get to network privatization. as I said, there were all these different networks, and so TCP/IP kind of made it as a glued all these things together, but it was a rickety operation at best. And not only that, these networks were used primarily for academic or extremely geeky purposes. The idea of the average user having anything to do with the internet was still nowhere on the table. But then a little something called the World Wide Web came around, and people started to take notice. Suddenly there was human-readable text, yet you could change the font and style of. This was amazing. The ideas of having graphics, graphical user interfaces for the web, this was big stuff in the late 80s and early 90s. And so people started to realize, hey, maybe this network, this internet could actually be useful for the general public, people like you and me. And so expansion started to, they wanted to expand it, but the internet and its relevant smaller networks were being run by academic institutions and the NSF and other organizations that really had no business in trying to service a network for the general public. So they saw privatization as the means to go, as the way to go. Telecoms like AT&T could suddenly take this over and add, this new internet to their already existing copper telephone lines. And this is how we had our little fun known as dial-up. So that's how the network started to become accessible to the average person in the early 90s. But there was another aspect to this, and this is where the whole governance thing starts to come in. We may know, as you know, the internet's inventor, Al Gore, became vice president in the early 90s, and he had been working on technology issues for a couple of decades prior. And once he was in the vice presidency, he was really able to make this a central component of the administration. And he came up with this term, though the information superhighway is the one that stuck, but for policy purposes, this was all referred to as the National Information Infrastructure, this emerging technological network that was going to better the lives of everyone around them. So they set up some information infrastructure task forces to discuss some of these technology policy issues that they could foresee arising as this internet became common. Now, for those of you who are curious about the 1996 Telecom Act, too bad. This is occurring in a different sort of space than what I'm about to talk about, and was really more centered at the FCC. I'm about to talk about stuff that was more focused at the White House and Department of Commerce. So, but before I get to that, one thing I want to mention is that this was not simply an American initiative. A lot of this was happening in the American White House, but they recognized that this was going to be a global phenomenon. So many of the people involved were not only just working here, but they were going to meetings abroad. They were trying to talk about how can we connect to users abroad, users in Europe, users in Asia, users in Africa. These were questions even then, even before the internet was as prevalent, anywhere near as prevalent as it is today. And they strove for, generally admirable goals, universal access and open competition, and different settings that could make the internet easily usable and accessible by anyone. Now, e-commerce was actually a pretty big topic that got a lot of attention, particularly when we're talking about international commerce. Now, buying stuff on the web, oh, big deal today, right? But of course, we're talking about a network that in the late 80s was used strictly for research purposes and in fact was forbidden from having any commercial content posted to it. Think about that. Think about trying to talk about e-commerce on a network with that kind of history. And not only that, try to think about e-commerce between nations which have vastly different tax laws, different other sorts of regulations when we're talking about trying to buy and sell things. This is huge, and security, mobile payment. I mean, we're talking about issues that people are still grappling with today at a time before the internet was in everyone's homes. So, but it was a good thing to be able to put on the internet as people started using it because people want to buy things. And so lots of people had their different opinions on it, but it really started to make headway when the Clinton administration set up its own little interagency group among the different government agencies to talk about this. But they really couldn't ever figure out a governance solution, and I haven't done much research on the modern issues of e-commerce, but I think they're still trying to figure it out. So now we have to get back to the question of who was actually at the table for these things. There are all these committees and all these discussions, that's great, but as I was mentioning, so far it was really mostly from the government. And so the Department of Commerce established committees for several key issues, apart from the ones I already mentioned, including intellectual property and online privacy and government information. Those committees each published very key reports. And, but the reports had differing levels of effects. The privacy paper was really sort of, I talk about loose, like, well, you know, you should, if you're a company using personal information, you should probably tell your users what they're using it for. Simple, right? But the IP, Intellectual Property Committee, was a whole different story. They published very strict and specific recommendations in favor of copyright holders. Their logic was, well, the internet is here, but we've got to fill it with content. And unless content providers are confident that their content is secure, they won't be putting their content onto the internet. It seems kind of logical, but then they kind of missed the step where users generate content themselves. And this whole new type of idea of information sharing that has arisen since then. So there was a lot of internet outrage and coordination, even in the 90s, around issues like these. There was particularly around universities and libraries and other types of digital eggheads who kind of saw these IP laws as threatening to them. They really were concerned that if these recommendations, worded as specifically as they were put into place, you know, all of a sudden the internet might, you know, turn into a place that was a little less desirable for them to be working. And this is without the benefit of hindsight that we have today. There was another organization called the Advisory Council, separate from the committees that I just talked about. Now, this was interesting because this was comprised of people from outside government. Everything else I was talking about to this point was made up of people already inside government, federal government. But this council included people from education, included people from universities, from research, from telecom companies, from technology, from big media, et cetera, et cetera. So we were talking about a council that was at 1.37 people strong from all these different areas. Now, you might imagine that having all these people in the same room was great. We get all sorts of debate going on and all sorts of ideas being exchanged, but then it kind of comes hard to come to consensus. If this committee with all these different people is expected to publish something, well, what exactly can you expect them to publish? The result were these sets of reports that were very broad and high level in terms of what they discussed. You know, we want to talk about educating users on these capabilities. We want to talk about getting internet into hands people. We want to talk about people being secure in their information, but also information being able to be used for opportunities like commerce, and we want property to be protected. Nothing that really sounds terribly objectionable, but it was very broad and high level, and it represented really the base agreement of what such a diverse group of people were able to come to. Now, as I mentioned, we had that thing with the IP committee and their very specific rules. There was also the Communications Decency Act proposed by Senator James Exon. That would have made it illegal to show any obscene content to a minor through the internet. Now, imagine trying to enforce that without severely crippling the internet as we know it. And in fact, aside from the public outrage that it provoked, it was declared unconstitutional the very year after it was implemented based on free speech issues. But the question is that, you know, the people who were from outside government who were involved, they had different levels of impact because some were, you know, people, the general public who were involved were pretty far back. They were some of them were very aware of what was going on. Some of them were very much less aware. Remember, we didn't have the internet to easily keep track of these things. So people had to do a lot more work to figure out what the status of these issues were and to even organize any types of protests or write a letter or anything like that. And then we had this council that was a little closer to the action because they had this formal affiliation with the IITF. But again, they were sort of one member among many who were all together trying to find the consensus of where people from all these different directions were coming from. And that seems like it'd be a little straining. So that was basically the policy that was happening. Oh, and before I forget, what actually happened with all this IP controversy? Well, there was this big back and forth. It actually took years of debate between the IP committee and the groups of academics and the groups of academics and universities and other libraries and other folks who found it objectionable. But eventually there was sort of snuck through the back door and a little international treaty provision and a lot of the usual politicking you might expect. And eventually we ended up with the Digital Millennium Copyright Act, which has caused no controversy since then. So sorry, now we can go to the Internet Society. And if you've been wondering since the beginning exactly what that is, wait no longer. It was founded by Cerf and Kahn in 1992 with the belief that the internet is for everyone. You know, this is, again, a pretty big change from the research network of just the decade prior. And they recognized that as this network became more prominent, there were going to be issues that developed, and very key social and policy issues that developed, that something like this really needed to be around to address. Its initial focus was to really sort of help the internet's technical development through something called the Internet Engineering Task Force, which really focuses on sort of protocol and packet engineering. But as it's developed, it's got this outreach, it's got pillars from outreach, technology, and policy. So today, the Internet Society actually has its hands in all sorts of internet-related activities, from comments on policies like SOPA to sponsoring international internet organizations like the Internet Governance Forum to even management of the .org domain system. So the Internet Society really represents one of the first attempts, one of the first efforts to get more people involved, people who weren't interested, who weren't already in policy or government or had any reason already to know much about what was going on with this thing. Today it has about 100 chapters throughout the world, including one right here in New York, to address the concerns of its local members. And another key organization that was founded in the late 90s was the Internet Corporation for Assigned Names and Numbers. It was this is what is in charge of managing the domain name systems, IP allocations, and protocol port numbers. This was a job that used to be handled by John Postel, but unfortunately he left. He died in the mid-90s. So they decided that he was such a powerhouse that they needed an entire corporation to do his job. Since then, there have been some long-standing concerns over ICANN's transparency and the fact that it was established by the U.S. Department of Commerce as opposed to an international organization. This has led many people who are from outside the U.S. involved in internet governance to basically say that the U.S. controls the internet, which I think is a little reductionist, but it did remain a long-standing issue. Now, for those of you in the know, you might be aware that ICANN has recently announced it's ending the contract with Commerce and intends to move into an international body, but exactly how that's going to happen is yet we're not really sure. And also, if you've heard something about the global top-level domain, that's ICANN's doing as well. And finally, these organizations like ICANN and ISOC really point to something called the multi-stakeholder model. Now, what is that? This is a change from, for those of you who are not political scientists, I'll fill you in, the traditional means of diplomacy and governance and policy agreements on a global scale was done through multilateralism. This is comprised of established states and diplomats and transnational corporations. We're talking about people on these types of scales here, which seemed appropriate before we had something like the internet. It was difficult to synthesize information about what was going on, and we as a people couldn't really communicate our interests and our ideas so effectively to the governments. So we kind of needed them to do a lot of this for us. But as the internet came into being, we had this multi-stakeholder model which seeks to bring every stakeholder in. That means if you are a user or otherwise involved with the internet in every way, you have a stake. But exactly how are we going to do that? And to this day, there isn't really a clear definition of what the multi-stakeholder model actually is or how it works. This graphic that I've got here is actually the only version, the closest thing I've found to any sort of definition of a multi-stakeholder model, any sort of clear definition. But even then, that leaves a lot of room for interpretation. And you can start to see how the history has led to very open questions of internet governance that have, and that's why we see a lot of debates today over issues like SOPA and Snowden and other issues in the internet where a lot of things really haven't been settled or defined all that much because they weren't defined back then either. But we do see how a lot of the discussions today mirror some discussions that were happening years and years ago as well. So the internet is a very young medium still, especially when it comes to its time in the public forum. And in terms of understanding how it's going to be governed and used, it very much remains an open question. It's not a utility that we can come to expect like electricity or running water. And many people do tend to think that way. But it is still something that is become inordinately central to a lot of what people do, a lot of what people in this room do. And it would be a mistake to not be aware of these key governance issues. So I'm going to stop it here and let David Solomanoff here take over and bring us into the future. Thank you. Thank you.
Oh, you can? Oh, this is good. Okay. All right. Okay, so to pick up the thread there with the multi-stakeholderism, the current debate in terms of things like ICANN, a lot has to do with the degree to which whether nation states alone or large multinational corporations and owners of media companies and that type of thing should have the primary role in internet governance, whether NGOs, civil society should have a role and what that role should be. But this is kind of misleading because now that effectively almost everyone uses the internet, everyone is a stakeholder. So the real challenge, I believe, and we're working on this particularly with the Internet Society of New York, is to educate more people about internet governance, because there are lots of people who are, say, politically active in other ways in their local communities, that even at the federal, state or national level involved with politics, who don't understand anything about or even know, even if they use the internet, that there is such a thing as internet governance. So I'm going to jump to the next level here. We've figured out who the real stakeholders are, and now let's go to another level. And the motto of the Internet Society is "the Internet is for everyone." The founder, Vint Cerf, also has been involved with the different initiatives in terms of things like the Internet of Things. So he likes the Internet is for everything. But now we're going to take a quick look here at the bigger question of who is everybody and what is everything, and where is the internet, where is cyberspace going? So in terms of basic, users of the internet, the new users are coming from developing countries, and typically the mobile, like a smartphone or a tablet, is their primary means of access. The ongoing problem with new users of the internet tends to be that over time they are technically less sophisticated. At the same time, cheaper, more powerful hardware becomes available. And in the case of mobile devices, most people here, I'm sure, are very pro-open source and the open source model, but as you know, things like tablets and mobile phones tend to be more locked down, more proprietary software. It's harder to install open source software on them. And of course, as probably many people here are aware, the open source model is a better security model and not a perfect one, but it allows for better auditing of security problems. So we're kind of moving in an area where we can expect more security issues at the end user level with new internet users. We also see the same problem in terms of the IoT, as it's known, the Internet of Things. A recent Wired article I just read the other day had a situation with hotel rooms where they had were using a wired communication protocol that was intended for wired communication, so security is pretty simple there. But it was used for guests at hotels to turn on the lights and the air conditioner with an iPad. But they adapted that wired communication protocol that had no security, put that on a wireless network because it was just the easy thing to do. And so, of course, that meant that if you're a malicious hacker, you could turn off somebody else's air conditioning on a hot day and that type of thing. So we may be seeing more incidents of that as there's a push to take things in the same way. At the early days of the web, there were, the corporate mainframe was put online sometimes for e-commerce without proper consideration of security. We may be seeing a lot of incidents in the world of the Internet of Things with devices, embedded devices, sensors and such, where there are security problems. We're looking at a point where the Internet of Things and wireless connected devices like sensors and the like are going to be expanding massively because of a couple of trends here. Most people here have heard of Moore's law, that every 18 months a new computer chip has got double the density in terms of transistors on it. There's also something called Kuhme's law that is similar for actual energy efficiency in electronics. So that is to say that the actual power that's needed to operate a certain type of computer with a certain capacity is dropping massively. And what that means is that there's an interesting, Charlie Strauss, a futurist and sci-fi author, recently had an interesting blog post where he speculates that by 2030 that a city would be able to cover every square meter of the city with sensors or embedded devices that would be quite powerful for the cost of currently what it costs them to clean the streets. So naturally there's a lot of data and there's major kinds of privacy issues there. At the same time, it cuts two ways. If general purpose computers become tiny and ubiquitous, we can also have cool things like this, which okay, let's see, go here. Okay, right. Okay, all right. So, oops, whoa, okay, sorry, folks. Okay, yeah, that's right, okay. Can we page down here? Okay, so this is a Raspberry Pi that's been set up specifically to be used as a Tor router. And it's pretty inexpensive. This is from the Adafruit website, and it's like $100. So you can imagine that in a few years that it would be possible to make lots of these incredibly tiny, incredibly cheap, and distribute them throughout, say, an urban area. So on one hand, you have problems with surveillance that becomes ubiquitous, but at the same time, you have the ability to route around damage and censorship and the like in a way that it's never been possible before. Okay. Yeah. All right, there we go, back to, okay, so, right. Okay, so now what else, how else will the internet change? Well, okay, Vint Cerf, another pet project of his is the Interplanetary Internet, and that actually is not an attempt to communicate with space aliens. We'll maybe get to that later, but it's basically a way to adapt the internet protocol for the long distances and interruptions of space travel, but also has other kinds of interesting applications because it's basically delay-tolerant networking where interruptions and problems of that type can be worked around in a way the current internet protocol cannot be. So it could also be used in a situation where there is some kind of major natural disaster, breakdown of telecommunications infrastructure. The Interplanetary Internet protocol could handle that better. It could also be used in some cases where a repressive government interrupted telecommunications services. And a third application that's being looked at a lot is the use of scientific and environmental research in very remote places where there isn't normal infrastructure as well. So if you're studying wildlife migration in a distant area, you could use you could use the Interplanetary Internet protocol to more effectively, put sensors in that place and collect the data from them. Another cool thing that Vint Cerf and musician Peter Gabriel have started is the interspecies internet. So again, our definition of a multi-stakeholder is expanding quite a bit. The interspecies internet is an attempt to communicate with intelligent creatures that are not human, like dolphins and such, using different kinds of digital interfaces, teaching them to, for example, having a really waterproof, of course, a large tablet computer which a dolphin might learn to, bump with different sections of the screen, the touch screen with his nose, and learn to communicate that way. So obviously, down the road, we may be looking at some very different kinds of stakeholders in the internet. Another more bizarre and slightly disturbing trend is the use of military applications for animals that involve different kinds of implants and the like. One particularly bizarre one is DARPA's HIMEMS, that's an acronym, project, which stands for Hybrid Insect Microelectrical Mechanical Systems. And what they were doing there, and I have, as of about 2011, I couldn't find anything more up to date on this, but it was a long-term project for about 6 or 7 years. They were embedding electronic devices into insect larvae so that as the insect came, to be an adult insect, they would actually be able to control the insect's movements with the idea of basically, as bizarre as it may sound, making cyborg insect warriors. The idea is initially that they would fly around and could do reconnaissance, but I suppose if you've got a really, venomous insect, with, you could use it as an assassin too. But again, the point is here that, basically anything electronic now is likely to be connected and often wirelessly to the internet. So, the cyborg insect warriors are also stakeholders in the internet potentially. To move now we're going to go reverse direction here. So now we're talking about who's coming online. Now I'm going to move to our jumping a little bit further into cyberspace with virtual worlds and augmented reality. And virtual worlds are taking off at a rapid pace now in things like immersive online games and the like. And you may think, if you're not a gamer or into such things, that it still seems that the resolution and the actual quality of the experience is very poor, and that you can't imagine people really living in cyberspace quite yet. But the brain is hardwired to respond to two things without questioning whether they're real or not. And one is threatening stimuli. So if you're threatened, you don't worry too much or question too much if something's real because you don't want it to hurt you. Conversely, if something pleasurable, hey, why worry if it's pleasurable or whether it's real or not either? So, for example, a really sophisticated, well-designed game might switch, rapidly between threatening and pleasurable stimuli to the degree that it becomes very immersive, even if, again, the resolution of, say, an online game, the imagery is not really ultra-high resolution or realistic. You can become very, very absorbed in it. And we're all, at the same time, we're moving towards the increasing use of, currently for medical and military applications, things like implants for people who are hard of hearing that are network connected, bionic eyes or implants, the optic nerves for people who are blind or have visual problems. But obviously these types of things can be used just as a general purpose in replacement for the current monitors that we have. So basically we're looking at a situation where the sense of self will be changing rapidly if you have this stimuli that's coming from cyberspace or somewhere else feeding directly into your brain. Your sense of what your body is and your sense of self that way will change very rapidly. And also what we're seeing is a shifting sense of self and loyalty to institutions that's changing, partly because of things like younger people feeling alienated, having economic difficulties and so forth. One study found that people's life satisfaction with their lives in the real world was kind of inverse to their satisfaction in their, say, if they do a lot of things in Second Life or what have you. Their Second Life existence, if that was very positive and they were very happy, it was probably because their physical life in the physical world in meat space was not as good. So we're seeing with people who are younger people who are being, due to economic disparity and other kinds of issues, alienated from political and economic systems in the real world, moving rapidly to spending more and more time in virtual worlds. The other interesting thing there is that, this is a fairly recent study, but a couple of years ago, that at that point, the users of online games and virtual worlds typically had 4 avatars. So now each stakeholder has now been multiplied by 4. We have 4 people for online personalities for every person. So things are changing that way. And these the growing presence of people, or the movement of people into virtual worlds and online games, and that virtual environment presents a lot of interesting challenges to the traditional nation state. So basically the concept of, I'm citing Mark Goodman, who is a law enforcement consultant who specializes in cybercrime and cyber terrorism and information warfare. And he talks about how the concept of virtual reality is pretty new to law enforcement agencies around the world, yet more and more people are spending more and more of their time in the virtual worlds, and the full range of criminal activities that we see in the real world is rapidly migrating to cyberspace specifically in terms of virtual worlds, where things like money laundering, theft of intellectual property, exchange of child abuse images, and the like are occurring without the same kind of awareness in terms of law enforcement. Currently, most virtual worlds are kind of siloed environments, like a company like Second Life has proprietary software, a very centralized kind of architecture, but that's changing too. A person you've never heard, everyone here has heard of Tim Berners-Lee and knows that he invented the World Wide Web. Another person is probably, I think in a few years will be seen as important as Tim, and her name is Cristina Videra Lopez, a computer scientist based out of the University of California. In 2009, she developed the hypergrid, and that's an open source technology for doing what in virtual worlds what the web does for the internet, so that is, it makes interoperable virtual worlds, so you can go from your avatar can go from one world to another. And this opens things up radically, but it also presents interesting problems in terms of intellectual property and that type of thing. What can you take from one world to the next? Some kinds of issues, much more complex, but similar to ones that have mostly been dealt with in the web a long time ago. In addition, there's now an open metaverse currency that allows transactions across these different virtual worlds, and they can be converted to regular currencies, bitcoins and US dollars and that type of thing. So I was talking a moment ago about the change of sense of self and identity that people experience through things like immersive technologies, virtual worlds, and also implants. And these present a lot of interesting questions here too. DARPA is currently working on mood-altering implants to help people with post-stress traumatic PSTD. So they're looking to be able to alter people's moods with brain implants, which of course will be connected to wirelessly most likely, as increasingly medical prostheses are. And who else is going to be on the internet? Well, you think of we've already determined that people are becoming several people in terms of different personalities on in cyberspace with their different avatars. But it gets a little stranger here. DARPA also is working on a type of sensors that will recognize basically when you're experiencing a threatening situation, you sense it unconsciously more quickly than you respond consciously. So to speed things up in the battlefield, they're looking to develop different kinds of monitors that will recognize the unconscious reaction to a perceived threat and allow a soldier or help a soldier by having his electronic gun sight on his weapon start to look for the target before he's even aware that he or she has identified a threat. So basically, the unconscious mind is going to have its own, input on the internet, separate, and this will could be obviously developed into other kinds of applications and a different sort of thing where you can maybe deny that you did something because my unconscious did it, but it wasn't me. In any event, obviously these kinds of more invasive types of interfaces present major kinds of security issues that haven't been, again, the technology is running ahead of where security is being, and it might be bad if somebody, breaks into your bank account and steals money, but if they start, controlling your arms and legs and your impressions of the world, that's a little scarier. And so there is a reaction to all of this, so that, and of course, more mundane kinds of security issues we've been all very aware recently, like the Snowden revelations, and a bit of a reaction to it, so that both the Kremlin and the German government, for example, are reverting to paper and manual typewriters for critical high security communications in their organizations. A favorite a visionary sci-fi author of mine, Philip Dick, wrote a novel many years ago called Ubik, which described a part of the story involves a prudence organization, which employed people with sort of inverted kind of psychic abilities. Not that they weren't psychic, but they were able to block other people's psychic abilities because telepathy was being used in industrial espionage. So if you had a company where you were concerned about another company might spy on you, you'd hire an anti-telepath to accompany you when you went into a conference and you were going to discuss some sensitive stuff. So where this all is kind of grim and scary stuff, basically, we need, it comes back, I think, in the end to the fact that in the end, human beings develop technology, even if the technology then can, promulgate itself. And ultimately, what has to be built into the technology is an ethical sense. And as machines become more intelligent, we need to do that even more so. Eben Moglen, who is a friend of the Internet Society of New York, an important software freedom advocate and did a lot of legal work for the Free Software Foundation as well as teaching at Columbia, warned specifically about mobile devices that knew too much and whose inner workings were not understood. And he suggested that there be basically that the ethics, some kind of ethical behavior be programmed, hardwired into intelligent machines. And he was kind of thinking a little bit of, Isaac Asimov's I, Robot, of course. There's now a really pretty cool organization called the Open Roboethics Initiative, which is a think tank that's addressing issues of ethics as they pertain to robotics, and trying to take an open source approach to it, looking to the development models of Wikipedia and Linux too. The final question here, I guess, and this gets back to the issues of a little bit of internet governance. The real question is whether a human community can get to the Internet Engineering Task Force credo of rough code and consensus, whether rough consensus and running code. I knew it was something like that. Whether before the machines can go on to their, act out on the worst impulses of human beings, and then ultimately onto their own unknown agenda before we can stop it. So, thank you.
Thank you very much. I bet you weren't planning to hear about cyborg insect warriors today. All right, so I think we'll start to take questions now. We might want to turn up the house lights a second. There we go. Thanks. There you all are. All right, so if anyone has any questions, we'd be happy to field them. Oh, yes, and how could I forget?
Oh, okay, right.
Oh, it's on.
Question slide indicates it's question time.
I have a question more about the sort of mechanics of the Internet Society and ICANN and such as it currently exists. You'd mentioned, I'm familiar with the ICANN, like trying to distance itself from being a U.S.
Run by the Ecommerce department.
Yeah, the Commerce department. Is there been any discussion of like moving it underneath the Internet Society or having its own, being its own thing, or?
The Internet Society is taking more of a role in ICANN recently, so that we have people who are on the different kinds of committees and oversight organizations for ICANN. Also, and this is a good thing, and this is why you should join the Internet Society and get involved with your local chapter. This is the sales pitch. There are like caucuses within ICANN. They're called at-large structures, and in the past, a few Internet Society chapters were at-large structures, including ours, the New York one. But that's changed radically so that now about 50% of the at-large structures are actually Internet Society chapters. So the Internet Society is taking more of an active role. They're not going to take over or control ICANN, but have a growing role in terms of advocacy, and are really very much pushing for greater accountability and transparency.
Thank you.
Yeah.
Hi, my name is Kevin Kieran. I'm from Atlanta, Georgia, and full disclosure, I'm more of a political activist than I am a tech person, so bear with me. But one of the issues that I work on in Atlanta is the issue of autonomous weapons that's coming up more recently. There's going to be some more work done on this in the international community coming up here. And I talked to Mark Gabrud, who's a scientist. He suggested a ban on autonomous weapons in 1988. I'm curious, like, where you see this going and kind of what needs to be done. There's a researcher in Atlanta who's working on it right now, and the DoD wants him to do it. So I'm just curious in your thoughts on that.
Well, yeah, I'll let David. I'll just start by saying that I think a total outright ban or total outright support of anything is an oversimplification. I mean, because as with any software or technological item, an autonomous weapon system is made up of different parts. I mean, really, it's the weapon parts that's dangerous. The autonomous part, maybe not so. You take away the rocket, there's not really much of a threat. So I think that, so the question is, would we ban this technology or maybe ban, the use of the rocket? Or I think that in order to answer that question fully, we'd have to break it down.
Sure. There was a DoD directive that kind of defines what the U.S. is calling autonomous weapons, so that's kind of where my head's at. But
right, there are autonomous weapons now in place in certain parts of the world, like the DMZ in Korea. They have both sides have autonomous weapons there. They're fixed, basically guns with a computer that will identify a target and shoot at it. A while ago, I was at the drones and aerial robotics conference, which was, I think, down in at the New York Law School. And Daniel Suarez, who is a sci-fi author with a military background, gave a great, fantastic talk. He just wrote a novel about the subject, specifically about both autonomous weapons and autonomous weapons that could join swarms or act in groups independently on an ad hoc kind of basis. And what he suggested is that all drones have a cryptographic signature hardwired into the main circuit board of the device that would always identify themselves, and that any kind of drone that did not have this would immediately be assumed to be hostile and destroyed. So that would basically be through this digital fingerprint, it would be possible to identify them. So that was his technical solution to it.
Thanks. Great talk.
Sure. Thanks.
Yes, definitely great talk. Thanks very much. David, you mentioned, you talked briefly about ambient connectivity, so Bob Frankston's idea. And for myself, I think that's really essential for an open, pervasive Internet of Things and the community of the future. In the previous talks, we talked a lot about ISPs, Comcast being everywhere, and all this incentive to block something like ambient connectivity. I'd be curious how you see it possibly playing out, the challenges.
I think it's a real cool idea. I'm not quite sure how it exactly would be implemented. But to pick it up and just to clarify ambient connectivity, Bob Frankston invented the original spreadsheet VisiCalc, but now he's smart guy's gone to other things and is pushing this idea of ambient connectivity that basically, in the same way that we don't, take streets and sidewalks for granted, that connectivity to the internet should be as accessible as that. And his idea is that rather than breaking down the silos between different kinds of services, so that, for example, you might walk down the street here, and if you were to take out your smartphone, you would see that there are many, many different Wi-Fi hotspots and things like that, but that they're locked down. And basically there's a lot of redundancy there. We talk about a bandwidth shortage, but actually there's a huge amount of bandwidth that's not really available. So that basically if you could do something along the lines of mesh networking across topologies and networks and make all of that connectivity available to anybody who needed it, with some kinds of restrictions, that would be a good thing. That's his model. And the business side of that, or the political side, I'm not quite sure what the solution is. It's a very cool idea, though.
In order to probably fully implement a vision like that, I don't know if TCP/IP can take us all the way there. There are talks on emerging internet architectures, which probably we should have talked about a bit. But one, specific type of content delivery networks. This is often used as an example as Netflix. Rather than trying to, if you're trying to watch Netflix and it's a busy time of day, you shouldn't just request the main Netflix server. There should be content servers that can provision the content closer to where it actually needs to be. And if we stop talking about IP addresses and start breaking down internet content in terms of what it actually is, then we can start to get to where we're trying to go a lot quicker, and ambient connectivity becomes a lot more possible in that kind of context.
Awesome. Thanks for sharing your thoughts.
Hi. First off, thanks for your talk. It's fascinating. My question is, I think the internet's one of its greatest strengths has been its lack of regulation, its lack of any of these current political structures that we have in most other areas of life, and it's allowed a great amount of flexibility. Is that something that we really want to be aiming to have more of in the future, or is the current chaotic architecture actually like a great strength and something we should strive to keep?
I'm sorry, the current what architecture?
Chaotic architecture.
Oh, chaotic? Yeah, we want to, the design of the internet in terms of being kind of permissionless, in terms of your being able to offer a new service on your own server and so forth, that is very important. And certainly something that we at the Internet Society, and particularly of Internet Society of New York, but want everyone to be a first-class citizen on the Internet. That is to say, a lot of times if you have residential broadband service, it's really designed for you to be a passive consumer. It's asymmetrical. You can't upload as much as you download, and you may not be allowed to have servers in your home. According to the AUP, acceptable use policy or whatever. And we're very much for a decentralized model and things like mesh networks, and outside of security and other kinds of real law enforcement kinds of issues that are legitimate, that people should be able to do what they want. That's very much what we're about, and including independent community networks and that type of thing. We're very much for that. Yeah.
Sure. Thanks.
You talked a little bit about the robots becoming autonomous and doing whatever they're wanting with their nefarious. Could you talk a little bit about your thoughts on the Kurzweil thing and the exponential increase of technology and the singularity, how that
Well, I have an opinion about that.
Yeah,
is that the question?
Right. I'd like to hear your opinion.
Yeah, I just saw him give a talk the other day. I have a couple of thoughts. One, I'm a technologist. I believe that there is something beyond our current technology in terms of the human spirit and consciousness and such. And I think that I don't think that machines are intelligent in the way that humans or living beings are, and that the type of intelligence that we have is radically different. I think the biggest thing to do is to understand how our current technology is really different, even if it's supposedly intelligent, how it's different from human or organic sentient consciousness, and to understand some of the ethical and moral issues there. I think that's very important. My crystal ball is a little cloudy here. Probably Moore's law is going to continue more or less, and Kumi's law and the like, and so that the current kinds of technology are going to get more powerful. But I don't really know that they are the same as organic technology, technology of our brains, or the ineffable thing of consciousness, which may be something very, very different. And I'm a spiritual person. I believe that there is something outside of the material. That's my opinion, and that we're not going to duplicate that with the current technology ever. And if we ever got close, it would be because it really changed a lot. It was very different from this.
Could you comment?
Oh. I'm pretty much in agreement with him in the sense that we understand. I mean, we have to understand that even today's top artificial intelligence isn't really intelligent. The artificial intelligence is designed to do a particular problem. It's designed to be really good at Jeopardy. It's designed to traverse a lot of terrain. It's designed to make autonomous decisions about where to go. What the beauty of I guess human and animal intelligence is that it's dynamic. It can learn new things without really being programmed to do so. It's extremely inventive. We have an understanding of aesthetic and beauty, and my timer's getting close, so I'm going to cut it there.
Thank you.
Thank you. No problem. Yeah, last question.
Thank you. It was a very nice, comprehensive introduction to the internet governance issue. I just wanted to comment quickly that what you mentioned about the multi-stakeholder model, that please do not make the mistake to consider multi-stakeholder model as a problem of representation, because the old national governance model in the world, it was based of the concept of representation, structural representations, and the whole idea of multi-stakeholder model tries to break up that idea of representation and instead build up freedom and liberties for people in a democratic sense to open up and raise their own issues. So
I'm not, when I say we couldn't define it, I'm not trying to put it down. I mean, absolutely, I think the multi-stakeholder model has done wonders for the internet society. The problem is that when we try and talk about what is it, point to it, how does it work, how do we manage it, those become trickier questions. But in terms of which internet governance model is best, I think certainly the Internet Society believes that the multi-stakeholder model is the way to go. That just doesn't mean we can't, we may just be able to tell you exactly what it is.
Thank you.
All right, thank you very much, everyone.